Hi. In this video, we're going to be doing 3 examples where we find the inverse of functions. So in this first example here, and in all the examples after this, we're going to use 4 steps. So the first step, I'm going to take, and if it has an f of x, I'm going to replace it with a y. So we have y is equal to 7x minus 5. For my second step, I'm going to take and change all the y's to x's and all the x's to y's. Then the third step, which is usually the longest and hardest of the steps, I'm going to take and solve for my y now. So my first step here is I'm going to add 5 to both sides. So I get x plus 5 is equal to 7y. Okay, and then I'm going to have to divide both sides by 7. So I get y is equal to x plus 5 divided by 7. Now you can divide the bottom part into both parts if you want to make it look linear, because it is a line, it's a linear function. So you'd get 1/7 x plus 5/7 if you want to. You don't have to do that. All right, and so my answer for my fourth step, I'm going to take the y and replace it again with the inverse of f of x, because I am done with this problem. So I get the inverse of f of x is x plus 5 over 7. Now, in most of these examples, I'm not going to check the answer, but I do want to make sure you know how to do it. So to check your answer, what you do is you take the inverse of f of x and plug in f of x where the x is. So basically you do a function composition, you do the inverse of f of x. All right, and so in order to do that, I take f of x and plug it in where this x is. So I get 7x minus 5 plus 5 all over 7. So what happens here is this minus 5 and plus 5 cancel each other out. I get 7x over 7. Now the reason why I put this in parentheses right here is if there was some number being multiplied by x, I would have to multiply all of this by that number first. Okay. Now luckily there wasn't anything out there, so I just dropped the parentheses. All right, for my last step here, 7x divided by 7. 7 divided by 7 is just 1, so I get just x, which is exactly what we should get every time you do the function composition of your inverse and the original. Example 2. So this time we're finding the inverse of x cubed minus 1. So same steps as before. Step 1, I take and I replace f of x with y. So y is equal to x cubed minus 1. Step 2, change all my x's to y's and all my y's to x's. So I'm just switching my inputs and outputs. Step 3, solve for y. So in this one, I add 1 to both sides. So I get x plus 1 is equal to y cubed. Then I need to get rid of this cubed. And I do that by taking the cube root of both sides. So I take the cube root of x plus 1. All right, y is by itself, so that means I only have one step left, and that is to replace the y with the inverse of f of x. So I get that equals the cube root of x plus 1. And once again, I am done. So once again, to check it, you could plug in this part in for x right there, and you should get x. Now, before I go on any farther, sometimes you do have to be careful about writing this function notation. Here's a bonus example. All right, let's say we have f of x is equal to x squared. Now, remember, you're changing your inputs and your outputs, which means you're also switching your domain and range. Because sometimes these things aren't functions when you find the inverse. All right, so when I do this, so step 1, change f of x to y. Step 2, change my y's to x's and my x's to y's. Step 3, solve for y. So I get the square root of x is equal to y. Now, the thing is, when you take the square root you got to take the positive and the negative values. Because, for example, if y was, or if x was 4, the square root of 4 is either positive 2 or negative 2. You can get both, both would work there. So that being said, uh, I can't write this in function notation anymore. The reason being, my input gives me two different outputs. So in order for this to actually have an inverse function, you're going to have to limit your domain before you switch over. All right, time for the third and final example. This one's also pretty complicated. All right, so the reason being is it's a rational function here. So I'm going to still follow the same exact steps. My first step, I change f of x to y. So get y is equal to 2x plus 1. Now divide it by x minus 3. Step 2, change all the y's to x's and all the x's to y's. So you get 2y plus 1 over y minus 3. Okay, for the third step, I have to solve this thing now. Okay, I have to solve for y. Now, the way that I've found that students like best is to put this side over 1 and then cross multiply and then solve. You could also think of it as getting rid of the y in the denominator, but cross multiplying does accomplish that goal. So we get x times y minus 3. It's going to equal 2y plus 1. Now I'm going to distribute my x. We got xy minus 3x is equal to 2y plus 1. Now I've got y's on both sides of the equal sign, so I need to get them all on one side. So what I'm going to do is I'm going to subtract xy from both sides. So I get negative 3x is equal to, well, let me back up for a second. I want to do it the other way. I want to subtract 2y from both sides. So minus 2y minus 2y. And it really doesn't matter. You're going to end up with the same thing in the end anyway. They might look a little different because you might have negatives in places that you would have positives, but all the signs are going to be different if you have that problem. So if your answer doesn't look exactly like an answer somebody else gets, that might be the issue. All right, so I've got xy minus 2y minus 3x is equal to 1. Now I want to get these things by themselves over here. So I'm going to add 3x to both sides. And so I get xy minus 2y is equal to 3x plus 1. All right, so next, I'm going to factor out a y here. So I'm going to factor out a y since they both have a y. I get x minus 2 is equal to 3x plus 1. Hey, I only have one y now, and it's being multiplied by something. So I undo multiply by x minus 2 by dividing by x minus 2. And so my final answer, or my final step for solving for it, for y, is going to be divide both sides by x minus 2, and I get 3x plus 1 divided by x minus 2 is equal to y. Y is by itself, so now I can do my final step, which is plug in the inverse of f of x for y. So I get the inverse of f of x is 3x plus 1 over x minus 2. And that is my answer. All right, now what I was saying earlier about it not really mattering which way you subtract, whether you subtract xy or subtract 2y from both sides, the only difference it's going to make is that you're going to get something that looks like this. Negative 3x minus 1 over 2 minus x, or negative x plus 2. These two things are the exact same. The only difference is it's like you multiply the top and the bottom by -1, which doesn't change any values, it just changes the way it looks. Alright, well I hope that this video has helped. Have a good one.